Hello, hello, hello. Another day, another math video. Okay, like I said, there's only two sections in chapter 5 for Geometry 9. Wouldn't you like to know what's in the other sections? Well, I can tell you if you really want to. Okay, still dealing with inequalities and triangles. Now we're talking about like two triangles, but there's still properties within triangles. So this one is saying if we have two triangles, and we have the lengths of those two triangles are equal. There's two lengths of each of the triangles that are equal to each other. This is called the hinge theorem. If in between one angle, this angle is larger than this angle, what that is saying is the side across from it then is going to be larger than the side across from this. So it's kind of using the same property as in 5.6. Now it's just within two triangles instead of the same triangle. So looking at this next one, it's saying which one of these properties must be true. Well, if I'm looking at this, we have these two lengths the same and these two lengths the same. Now this is 98 degrees and this is 90. That means AC, because that's straight across my larger length, has to be greater than TR. So now if I look at that, which one? Not the same. Nope. RS, not using that. Nope. AC is less than. Nope. AC is greater than RT, which is the same thing as TR. Yep. Letter D. Now, the converse of that is basically the same thing, but thinking it in the opposite direction. Now, if I know the lengths of these are larger, whoop, that's angle. So if I know the length of BC right here is larger than YZ, that means the angle across from this. So that means angle A is greater than angle X. So now we're looking at this property. Now it's saying that we're going to have a range. We're going to have an upper limit and a lower limit. So in our hinge theorem here, we have that these two sides are congruent. We also know that this side is going to be congruent to itself. So now we can still use our hinge theorem. So because this side right here is 15 and this side right here is 10, that means 60 has to be greater than 5x minus 20. Okay, because 15 is larger than 10, that means 60 is larger than 5x minus 20. So I can figure out my upper limit. So if I solve this, the first thing I have to do is move that subtraction over. So the opposite of subtracting would be adding. And now I have to get rid of that 5 times x. So the opposite of multiplying would be dividing. So it's 80 divided by 5 would be 16. So I know that x has to be, I could also rewrite it like this if I wanted to, less than 16. In order to make this hinge theorem true, x has to be less than 16. Now, we also have this lower limit because when we're talking about an angle, this angle, in order to make it an angle and not a line, is we have to say that this angle has to be greater than 0. It could be 0.01, it could be 0.0001, but it has to be greater than 0. So I do not have an or equal here. So the first thing you do is move over that subtract 20. So opposite of subtracting would be adding. Opposite of multiplying, because we have multiplication right here, would be dividing. So we know that my upper limit, x has to be less than 16, but our lower limit, x has to be greater than 4. So that's using that hinge theorem with an upper and lower limit. Now, the second question is asking for the converse of this. So it's the same type of thing, except now we're using the converse. And it's asking, so I often say don't go off the picture, but in this case, we're going to go off the picture. So in this case, because this is a 90 degrees and this is creating an acute angle, we know that this angle is going to be smaller than that. So I know that 90 has to be greater than the 4x minus 8. So I want you to pause the video. Actually, and then our lower limit is that the angle has to create an angle. So pause the video and solve both of those two equations. So x has to be less than, because again, I can rewrite this. Sometimes people prefer to rewrite it so that when they read it, x has to be less than 24.5 or x is greater than 2. And last but not least, look at this. We have a proof. However, we're not going to do this. Boop, boop. There you go, guys. Have a great, grand, wonderful day. See ya.